Sometimes this is referred to as defense in depth. You know, and this is really one of the foundations of the security architecture is the requirement to implement multiple layers of security. Requires that organizations establish sufficient security controls and safeguards so that an intruder faces multiple layers of controls, and keeping in mind that we recognize that no one layer is going to prevent an individual from gaining access. It's just going to deter them or maybe dissuade them. The perimeter of a particular organization is the point in which the organization's security protection ends and the outside world begins. This is often referred to as the perimeter. It is the gate to our organization. It is the farthest outward reaching point of our control. Unfortunately, the perimeter does not apply to internal attacks from employees, threats and then on-site physical threats as well. So we have to remember that. Not only must we put controls in place that point outward, but we also have to keep our controls pointing forward or internally as well. Some typical types of things that we would see as we look at the design of security architecture, one of them being a firewall. A firewall is simply a device that selectively discriminates against information flowing into or out of an organization. It's usually a computing device or some sort of specifically configured computer that allows or prevents information from entering or exiting the defined area based on a set of defined rules. Everything behind the firewall would be considered a trusted communication. We would want to make sure that only individuals that are fully trusted or trusted are allowed in. Outside the firewall, we would usually see a DMZ or demilitarized zone, and this is kind of just what it sounds like, a no man's land between inside and outside networks, where some organizations would place things like web servers or STMP servers, maybe your antivirus servers, things that need to have access to the internet, but also must be accessed in a controlled manner from inside the organization. We would expect to see there. Sometimes it's an area of semi-trust. Other things that you might run into in your reading are proxy servers, and these things perform actions on behalf of another system. Most frequently you see this as it relates to internet access from within a controlled organization's network. Intrusion detection systems, these are systems that are put in place, and they come in a variety of functions or forms. They can be a network-based or a host-based or a system-based intrusion detection system. And really what they're looking for is behavior that is anomalous. In other words, it's out of the ordinary. They work in a variety of different ways. We'll talk about those in later chapters, but for now you should think of them in the physical sense. They're kind of like smoke detectors and carbon monoxide detectors, in that most of the time they're very passive and they're waiting to detect some sort of unauthorized or unusual behavior. A little graphical representation of defense in depth. Untrusted network all the way on the left there. Internal network is over here on the right, and what we've done is basically put a bunch of stuff, firewall configuration using 2 routers and a dual home host. More on that later. That's really screening out information or screening out access based on information contained in the header. And then internally we have our trusted network with a host intrusion detection system on the network. Looking at security perimeters, I mentioned it before, right? We have our untrusted network out here. We've created some sort of DMZ using a filtering router, and then everything inside our perimeter, right, our most forward, outward reaching area would be considered our trusted network. In other words, everybody inside is trusted, everybody on the outside is not. Another representation of some, firewall configuration using a bunch of proxy servers in here, a couple of filtering firewalls to create our DMZ over here, and then our trusted network inside. Okay, so let's spend a few minutes talking about the system development lifecycle, and then we'll, bleed it into the security system development lifecycle, which is pretty much the same thing, just using an implementation of security as opposed to a system. So system development lifecycle is basically a way to reflect that information security must be managed in a manner similar to many other major systems implemented within an organization. And the best approach for implementing information security systems is in an organization with little or no formal security in place is to use a variation of the system development lifecycle that I just mentioned before. It's the security system development lifecycle. Basically a methodology for the design and implementation of an information system within an organization. Using a methodology, some sort of formal practice ensures rigorous process and avoids missing those steps that can lead to compromising the end goal. And the goal is creating a comprehensive security posture. Basically, best described as a waterfall methodology that's cyclical in nature. It starts in a given location, and in this case, the security or system development lifecycle starts with investigation, moves to analysis, logical design, physical design, implementation, maintenance, and change, and then it goes right back to investigation again. And that's the way it is really designed to work. If we looked at the first phase, the investigation phase, this is really the most important phase, right? What is the problem the system is being developed to solve? What is the problem that the security control is being developed to solve? This phase begins with an examination of the event or plan that initiates the process. The objectives, the constraints, and the scope of the project are specified here. A preliminary cost-benefit analysis developed to evaluate the perceived benefits and the appropriate level of cost an organization is willing to expend to obtain those benefits. And at this point, we also do a feasibility analysis to assess the economic, technical, and behavioral feasibilities of the process and ensure that implementation is worth the organization's time and efforts, because this is an expensive process and we want to make sure we're going to get it right and that it's meaningful. The next step is analysis. The analysis phase begins with the information learned during the investigation phase. It's rolled forward. This process consists really of an assessment of the organization, the status of current systems, the capability of supporting the proposed system. Analysts begin to determine what the new system is expected to do and how it will interact with existing systems. This phase ends with the documentation of the findings and, again, another feasibility analysis. The next phase is the logical design. The information gained from the previous phase, the analysis phase, is used to begin creating a solution system or a solution control for the problem. Then, based on the need of the organization, they select applications capable of providing the needed services. Based on the applications needed, they select data support and structure capable of providing the needed inputs. Finally, based on all of that information, they select specific technologies to implement in the physical solution. In the end, another feasibility analysis is performed. And we have to keep in mind that throughout this process, if it's ever determined that the organization, cannot move forward, then the appropriate thing to do is to, end that particular project, go back, revisit, start over, and see if we can figure out another way of doing it. The next phase is the physical design. Here, specific technologies are selected to support the alternatives that have been identified and evaluated through the logical design. The components are evaluated based on a make or buy decision, whether we're going to develop these things in-house or are we going to purchase them from a vendor. And then final designs are begun to integrate components and technologies, and then we do another feasibility analysis. The entire solution after the feasibility analysis, and assuming we're moving forward, is presented to the end user representatives for approval. And this is important. We have to make sure that when we roll a new system out, whether it's a new system within an organization or if it's a security control, that we have the opportunity and we give the opportunity for the individuals that have to interact with that machine or that control the opportunity to look at it and give us an approval or provide us some feedback that says, hey, this sounds like a great thing, but we may want to change these things, or you may want to address these issues that we see.